code is just about making sure that you can communicate between the view and the model. Over here, here, we have the controller. You know what that is. So the controller is in charge of making sure that the model and the view agree, because it would be very bad if, say, for our demo GUI application, we have our buttons here. This says hello. Well, I guess it should be right over there. This is our demo GUI application. Let's say hello's in the top and the bottom. But the model has that the top input box says something else like world, and the bottom says something like world. It's up to the controller to make sure that these two things agree. Otherwise, the user will not have a good experience. You can imagine that if it were, say, a calculator and the model had stored that the user had entered in the number 23, but the view says that it is 46, and then it tries to do an operation on the number 46. But in actuality, what's happening is that it's modifying the value 23. The results are just going to be off. So that's the job of the controller. This is the dominant approach to organizing software with GUIs. It's the model, view, controller design pattern. This is actually true. Any sort of graphical user interface you see, even like iOS apps use this as well, where the model is sort of the ground truth of what is actually being stored, and then it is used by the controller to populate it to the view, what the user actually sees. There are several versions. We'll illustrate one that is clean as opposed to one that is dirty. There should be interfaces for the model, view, and controller classes. So there should be something like a view class or view interface, which is implemented by a view class, but they are omitted for simplicity's sake, especially in the GUI. Okay, so here's what we had on Tuesday, which was that we were doing everything in the view, which it goes against one of the core principles of CSE 2221, which is the separation of tasks. So just like how we separated out the implementer and the client, we too are also going to separate out all of the responsibilities of a GUI application into the model, the view, and the controller. So far, it's just like the previous demo GUI, except this is called view instead of, I think it was called like GUI main application or something like that. But that is essentially what the user sees. So our little text box example, everything was contained, all of the code contained in that was in the view. But we're going to extrapolate it out to a model view controller design pattern instead. So setting up and using all the GUI widgets is in view, but that is all. Here is the actual story. We add in the model and then the controller, and all the code related to the model or the non-GUI aspects is in the model. This is, well, in our example, it's just going to be like the top text and the bottom text. Because we are modeling that based off of strings. So this is just going to be a set of strings, which represents both the bottom and the top and the bottom text. And once we dive into the code, you'll see what this looks like. And then the code that mediates between the model and the view, often called the business logic, is the controller. This is like in sitcoms when view and model say that they're not talking to each other. So anything that happens to the view will be like, I'm not talking to the model, but controller tell model that a button was pressed, and the model says, okay, well, I'm not talking to view, but controller tell the view that it should add 1 to the calculator. Except they're perpetually fighting, and they never make up, and they never talk to each other. So you'll see the view and the model actually don't have a way to communicate at all. The only way that they're able to communicate is through the controller. So the controller has a reference to the view has a reference to the controller has a reference to the model has a reference to the controller. But the model does not have a reference to the view. There's no way for the model to automatically update and tell the view, hey, based on what just happened to you, this is what you should do. It first must go through the controller. Okay, demo time 2. We have a second demo called Demo GUI 2, which contains a very simple model view controller design pattern. So we'll go through all 3 of the things here. So you can see we have demo GUI, we have demo model, demo view, and then demo controller. These represent the model, the view, and the controller. Trying to decide which one to start with. Let's start with the view. So the view is going to look very similar to the code that we talked about on Tuesday. As you can see, the view has a reference to the controller. You'll see that when we get to the controller will have a reference to the model and then the view. And then when we get to view, you'll see that view has a reference to the controller. This is just so that the model can talk. Which one are we in? View. This is so that the view can talk to the controller and tell it that it has been, say, clicked on or a button has been pressed. This stuff should look exactly the same. These are the final constants that we talked about where you can update them and change things. We have our text areas, our buttons, and then we have the constructor, which sets everything up. So if we go into demo GUI, you'll see that all we do is call the new demo constructor or demo view, and this is what sets up everything. All this code is the same: input text, output text, reset button, copy button. All of this is the same. The scroll plane, the button panel dot add, set layout, add, reset button, copy button. And then at the end, what it does is it packs it. It sets the default close operation to exit. So get rid of itself when it's clicked on, and then it sets visible to true. While this is happening, while it's like adding the buttons, none of that is visible to you because the set visible is false, but it's technically there. It's just hidden behind the cloak of invisibility. So we add the text box and it does that. That's what it will look like in the back end. You're going to add the button and then it'll add the bottom one. But none of that is visible to you until you call this.pack and then this set visible. Okay, so that should look very similar. Then we have a method called register observer. This registers a whatever the controller is as a viewer or an observer, which we talked about on Tuesday. So the controller will now take care of being an observer of all the buttons of view. So we go back to our example. I don't know how many times we're going to draw this image, but we have like two things really that need to be worried about. The controller will have observers that are pointing towards the buttons. And when they are pressed, the view will tell the controller, hey, I've been pressed. All of your observers that are registered to my buttons, this is what has happened to me. The controller will then take those events that have happened. It'll have a set of instructions of what it's supposed to do. Usually it'll end up communicating to the model. The model will say, okay, based on what has been pressed in the view that the controller has told me has happened, this is what it should do. It'll say, okay, here's what it should do back to the controller. The controller will say, okay, here's what should happen back to the view. It's a very, what's the game? Telephone, where you say the word and then you pass it along, except it's computers. So there's no like latency or messing up the word. Okay, so registering the observers. We have update text display, which just takes in an input and then sets the input text of this to whatever it is. This is so that eventually the controller is going to call update input display after it knows what it's supposed to update it to. So this is a way of populating the changes from the model to the view. And then there's another one for the update output display, which does the same thing. And then finally, we have our action performed event, which should also look familiar. We get the source of of what has been done. So have I been pressed on the reset button or have I been pressed on the copy button? If it was a reset button, we have in the controller this process reset event and then this process copy event. So these are the methods that I talked about in the controller that take care of what should happen depending on when a certain button has been pressed. The project that is due next Friday, has a bunch of buttons because it's a calculator. And so there will be, your if statement for this will be very much different. It'll be very much longer. You'll have a process 1 button. You'll have a process 2 button. You'll have a process plus button. It'll be a very long if else chain that will look glorious when it's done. Okay. And then that's all that needs to be done here because there's only 2 buttons. Okay. That's the view. So everything that's related to what the user sees is contained within the view. That's all it's worried about. And it has no idea what's going on in the back end. It has no idea what happens after it dispatches this, hey, my reset button has been pressed. It kind of just stands there and waits for instructions. It doesn't know what reset event means. It doesn't know what copy event means. All it knows what to do is just listen to the controller. It's like an intern. And the controller is like the CEO, and the CEO just tells it, hey, update your output to be this. And the view says, okay, Also, a button has been pressed. I'll say, oh, well, and it talks to the model. The model's like the shareholders, I guess. I don't know, that's a bad example. Don't remember that. Okay, that's demo view. All the stuff contained within the view. Any preference? Should we go to model or controller next? Controller. Okay. Controller is the middleman or the business logic. So you'll see that we have a reference to the model, and then we have a reference to the view. This guy will be juggling all the tasks of making sure that they're in line. The main way that it does this is this update view to match model button, or this update view to match model method. At the bottom of every single method contained within the controller class, typically will be this update view to match model. Essentially what this does is it grabs all of the relevant information from the model that's stored here, and it propagates it to the view. So this update input display, you might remember from 5 minutes ago when we talked about it in the view, but actually we should be able to click on it. Yeah, this just sets the input text to whatever it is. But very simple method. All it does is it grabs the input or the model base truth of what is being stored in the program, and it populates it to the view. So just serving as a middleman. And you'll see we call this pretty often. It just takes in a model and a view, obviously, so that it can change them. And oh, here's an example of where it's used. The model and the view that we pass in are the model and the view that are stored as references to the controller. So really it looks, I'm going to draw it smaller, but it looks something like this, where you have your controller, which has a reference to the view, which is its own reference. This is its own reference. And then we'll call model over here. And then model is its own reference as well, with a reference to controller, and controller has a reference to model, and view has a reference to controller. So a lot of business logic just to copy text from the input to the output. But for larger and larger programs, it becomes way more useful to have all this stuff separated out. Because you can have somebody working on the controller, you can have somebody working on the model, you can have somebody working on the view, and they don't really interact with each other, which is nice. Okay, so when we set a new demo controller up, what we do is we set this.model equal to the model, this.view equal to the view. This propagates in here. So after we make the model and the view, we make a controller which has references to the specific model and the view that we just set up. That's why this.model equals model, this.view equals view. And then, of course, we populate any of the text that is in the backend to the front end view. Okay, here are the process reset event and then process copy events that were called in the view. In the view, I said. Okay, I guess it doesn't want to go, but they're down here. So when the view gets clicked on, it says, hey, something happened to me. I don't know what I should do. And then the controller says, well, I know what to do. This is what I do. So it goes to the model and it sets the input and the output for a reset event to just being blank. Okay, it's already blank up there. And then it updates the view to match that new model. So if we didn't have this line of code here, the back end and the front end would be out of whack. And when you clicked on a reset button, it would change the text from being whatever the text is in the bottom and the top to being empty on the model side. But on the view side, it would not update to be empty. And that would be bad because the user's spam clicking the reset button and it's not resetting the text. And then they leave a bad review on your app and then you're homeless. I don't know. Okay. Then we update the view to the master model. Okay. And then the only other event that we have to deal with for this small example is the process copy event. So this one is just a little bit different. It sets the input to the input, and then it sets the output also to the input, where the input is the string. So where we called this was here, and then the input was just whatever the input text was. So this is taking whatever text has been said in the view. Hello. We're passing that hello to the controller. So now it's here. And then we're saying, hey, set that equal to top text and bottom text. And now over here, this will be hello. And hello. And then what happens is the controller says, okay, now we need to update the view to match the model. So we say, hey, take this hello and this hello over here. Hello and hello. And now propagate it to the view. And now the top and the bottom will be hello. Technically, I guess you wouldn't need to set the top text to be equal to hello, but for pedantic sake, we do. And that's a controller. Controller will be, again, way more complicated for, say, your natural number calculator, because it will have to deal with like addition, subtraction, multiplication, and division. But it is the middleman, the communicator, the great communicator between the model and the view. It's like a translator at like the United Nations. There's another bad example for you, whichever one you want. Two siblings fighting or international relations. Okay. Only one we have left is the model. Okay. So-called model variables. Seems accusatory. Okay. And then here we store things as just Java things. So inputs and outputs. For your natural number calculator, you'll have like a top panel and a bottom panel. Those will be modeled by natural numbers. So you will have two natural numbers, like top and bottom, that you use to manipulate whatever the user is trying to do. Initially, we set them equal to blank. And then this one is actually even simpler. We just have a set input. We have a get input. We have a set output. And then we have a get output, which do, well, they do exactly what they say. Sets the output model to the string provided as an argument, returns the output model. And these are called by the controller in order to change things. So we set the output and we set the input. And then we grab whatever the output and the input are using the update view to match model method, which is up here. And then it updates the input display and updates the output display. And just in case you don't believe me, I actually haven't tried this, so let's hope. But if we run it, I don't know why it's still wide. I must have changed it. But we have, oh, I changed the, oh, I must have messed around with it. But if we have hello world, copy input, what it's doing is taking the text from here, bringing it over to the controller is passing it along to the model is updating it internally, and then it's passing it back to the controller and passing it back to the view. It's a lot of requests, there's a lot of communication, but the result is the same. And reset does the same thing. Okay, does that make sense? Because the first time I did this, I'll be honest, I learned it. I memorized enough that I needed for the final, and then I forgot about it. And I was like, I'll never have to do that again. And then they were like, you're going to teach software 1. And I was like, ah, gosh, I have to learn GUI again. So I had to sit down and learn it. But, once you do it 6 times, which is this is my 6th time doing CSE 2221, it makes sense to me. But I remember sitting in my dorm room being like, this is the stupidest thing I've ever seen. But it makes sense now. So does it make sense to you is what I'm saying? Okay, if it doesn't, then say something. Okay, cool. We can go through examples. I can draw more arrows. I can come up with a third example besides the UN or siblings fighting. Okay. Okay, that's the code. That's the code. And we could mess around with it, but I already put you through enough of that on Tuesday. Okay, it's demo time. It's done now. There is a demo GUI 3, so get ready for that. They say the trilogy is always the best. Okay. This is the picture that I drew. So you have your controller, you have your model, and you have your view. Oh, we didn't go over the main method. Just kidding. Back to it. This one's simple, though. What we do is we set up a model, we set up a view, and then we set up a controller which has references to the model and the view. Again, model and view don't need to know about each other. And then finally, we register the controller as an observer of the view. So this is a method which just registers the view or the controller as an observer of the view so that it can modify things. Actually, I wonder if this doesn't happen. I think this just breaks everything. But we'll see. Sorry, I lied. I know I said we weren't going to play around with the code, but. Oh, okay. That's what happens. You get a big long error. Null pointer exception. Okay, yeah. So make sure you register your observer. Okay, so this is what the photo looks like. And then the constructor sets up observers exactly like in demo GUI, but it's not illustrated here. And then afterwards, you can see that the controller has or the view has a reference to the controller. And then the model should have I don't know why it's not shown here, but the model should have a reference back to the controller so that it can modify things. And that's what it looks like. Okay, who's in charge? Once the main completes the initial thread, The event dispatch thread executes both the swing code that monitors the user interactions and all callbacks it makes to action performed methods. So if you remember, we talked about Java threads, where mess. I'm just gonna make space enough. But when we call main's entire job basically is to set up the model of view in the controller. And then it has that, what's it called? An event dispatch thread, which basically just means, hey, GUI is set up, my job is done. GUI, you can go for as long as you want until the user presses the button. And what it's doing is it's listening now for the buttons pressed or the text input changing, and then it has the that one method where it's like process object or process event. I forget. Where are you? It's in the view. Yeah, so now it just waits for this action performed event. And it does that for the end of time or until you put it out of its misery by closing the window. Yeah. So technically they're all in charge, but controller's technically mostly in charge. Okay, so view is what you actually see. View communicates with the controller. Controller tells the model what has been done. Model tells the controller to tell the view based on what has been done to do things. And that's it. There's only 14 slides today. But you have me for 30 minutes if anybody has any questions about model view or controller. I believe the lab goes into it tomorrow, maybe. Let's see. Yeah. So tomorrow you get a head start on the GUI for the natural number calculator project. This is what it looks like. Way more interesting than the whole top and bottom thing. But there's a bunch of buttons. You can imagine there's a bunch of J panels. There's a bunch of inputs and output windows. Tomorrow will be important because if you don't have the view set up for your natural number calculator, it's going to be way harder to do the controller or the model because you have no idea what you're modeling or controlling. So make sure you're in lab tomorrow. We actually are having lab tomorrow. I'm not going to cancel a Friday lab for the third week in a row, unfortunately. But yeah, tomorrow's lab is fun. So you finally get to dig into the GUI code. Okay, any questions? All right, gift of time. You guys can go back to bed or you have other classes. I don't know. I'll put the attendance code back up before somebody comes up and asks me. Yeah, you can ask for a project done.
I fixed the thing that he told me to fix the other day, and I think I figured it out.
Okay.
But then I think it should work, but then it gives me this weird error.
Do you mind if I? Okay, so where are you? In file equals use simple reader input file. Okay, so you're trying to read in a file called input.html, but it's not showing. I think it's because it looks at the top level directory first. So instead of being, let me see if this works. Instead of being index.html or input.html, try src/index.html. Oh, it's input.html. Okay, yeah, so, it looks at it from the top level, so it's looking in project 10. And the only thing it sees in the project 10 folder is all of these, so,
Okay,
input.html is not in there.
okay, I see. Thank you.
Mhm.
So I was looking at project 6,
Okay, yeah.
and you said like the only thing was like not forget to comment.
Mhm.
But like I wasn't like sure like what more to like comment.
Yeah, can you go into the methods? Yeah, so the main method you didn't write, so that's good, but for this, just explaining like why you're doing what you're doing. Like,
Okay.
like if I've like been through the project, so I know, but I don't know why I wouldn't know why you're doing while difference dot compare to 1 is greater than 0. I don't know like what like the effect of that is, if that
Mhm.
makes any sense.
Okay. Okay,
Um,
so would that be like 2 points off or like 1?
I don't think there should be 2.
Okay. But yeah, that was like the
Yeah, I can
only
go back
thing.
and change it.
Okay.
Just send me a Slack message so that I remember.
A what message?
Slack message.
Okay, yeah, thank you.
Just be like, hey, like we talked about the commenting, but yeah, some people go, it's weird. There needs to be like a fine line between not commenting your code at all, and then some people will comment like every line of code.
Okay.
It's like, I know what int x equals like 5 does,
Okay.
but like groups of text it like block together. So like if you go back down to the code, like sometimes you could be like, hey, these are like constants that I'm
Mhm.
using. Oh, those should also be constants. So like final natural number 1 and 2.
Yeah.
And they should be in all caps and put it at the top.
Yeah.
That's like best practice.
Okay, that should be like here, right?
Not up there. I would declare them unless you're using them like in a bunch of methods in your code.
Mhm.
Like if you're just using them for the root method, which you are,
Yeah.
just at the top of the root method, final natural number 1 equals new natural number.
Okay.
And then you could say like declaring constants for whatever purpose you're using it for.
Yeah, that makes sense.
Okay,
Thank you.
cool.
Sorry, I have a question.
Yeah.
For sorting the terms
Mhm.
and the project that's due tomorrow.
Yeah.
So what I did, I did create a method
Okay.
to sort the terms
Mhm.
separately, but because I saw that it would take like a very good amount of lines.
Mhm.
So what I did is instead, when I read the glossary file up here,
Mhm.
so I added a queue here
Mhm.
for the terms.
Mhm.
So, and then I enqueue it, I enqueue the terms
Mhm.
at the end here. But what I did is I only call the sort and the main in just one line, which I think is counterintuitive.
Right,
Down
terms of
here.
sort.
So I don't know if that's a good practice or.
I think that's good, because you need the queue, it's in alphabetical order that it needs to be, right? Yeah, calling dot sort is totally fine. It should be. Let me double check. It's been a while since I've seen let me look at the glossary. This project 10. Let me look at what the
Yes.
language is in 'cause sometimes they have very specific ways that you want to do things. Okay, the term shall appeal in the glossary. Okay, then yeah, if it sorts correctly, that's like a totally fine way to do it. When I did the project, I just had a method that would go through the queue and find whatever the earliest one was and then remove it. But I think because this is the one where, yeah, this is the one where you don't have like any typical instructions. So
Okay.
I think as long as it, I mean, sorting is probably a smarter way to do things.
Mhm.
And especially using comparator is pretty nifty. So I think that would work fine. Yeah.
Okay. And then the last question I have, for debugging purposes, I had to